Subject, we're doing DT, HL, paper 1. Should help SL too, so, or SL. And definitely just, let's crunch through these and see what we learn. This is N25, by the way, November 25. So let's go with this. We have athletes are awarded positions in a race based on the order they cross the finishing line. Okay. What kind of data is this an example of? So immediately, what do we learn from this question is the order that tells us it's ordinal, right? We're ordering things by, so 1, 2, 3, 4, right? This is ordinal. Nominal means we are categorizing them. Categories, right? That isn't, I think it's category. Sorry, category, right? Category. Categories. But we're not ordering them. We're just placing them into categories. Like, let's say age. We're putting them into maybe income brackets. We're putting them into, or maybe the type of comfort level they like. Soft, hard, right? If we're looking at a mattress, for example, or geography maybe, where they live, that's nominal into categories. Ordinal is we're ordering them. And ratio and interval are quite similar. Interval is when we have things like interval, it means we have like a clearly defined difference between options, right? So we have scales, different types of scales, temps, Celsius scale, Celsius. Then we have let's say decibel, sound, right? Or frequencies, and there's like a set interval, right? We say 5 dB, 5 decibels, 4 decibels, 3 decibels, 2 decibels, and we're not making it up, right? We have a set defined constant interval, so we know exactly what the difference is between each interval. And the zero, so what we can say is equal size between uh, between values or points. And ratio is the same thing, but there's an absolute zero, essentially. So the zero actually means there's nothing there. And so that would be a Kelvin scale of temperature. Or weight scales. And let's say, uh, what else is there? We have speed scales. When we have zero speed, that means we have absolutely no speed. There's nothing. Nothing is moving, and we know what that means. Celsius is not an absolute zero, right? It just tells us 0 degrees Celsius is the freezing point of water, but it's not absolute zero like we have with Kelvin. And so that's the difference. So clearly D. And question 2: which term best describes a person's sense of physical or physiological ease? Okay, that's comfort, right? That's the first thing. So comfort means ease, or feeling of ease, right? Of ease or satisfaction. While fatigue means feeling of tiredness, right? And alertness is level of vigilance, or let's say readiness for something, or the caution we have, caution towards something, right? Hopefully that makes sense. And physiological data is just a collection of data. It's not related to a person's perception or sense of something, right? And that's concerned with physical aspects of the body, physical body, uh, and tolerances, physical tolerances, as in how much the body can tolerate something, tolerate or let's say withstand, right? And yeah, we can move on to question 3. A work envelope. Hopefully that made sense, right? Feeling of ease, satisfaction. Yep. A work envelope is a fixed three-dimensional space where work activities take place. Considering clearance and reach, what combination of anthropometric data would be considered for work envelopes? Well, what we want to be using is when we're considering work envelope, we want to be using our maximum, right? Max needed space. And so that only comes when we consider dynamic and functional, right? Dynamic means when we're moving, uh, subject is in motion, right? Moving subject, uh, subject carrying out tasks, right? Our max only comes when we're stretching out, when we have our maximum reach, max reach, clearance, everything like that. So carrying out tasks, uh, let's say bending, uh, what else do we do? Let's say jogging, jumping, any sort of activity. So what we usually have is the primary zone and secondary zone. Right, we have a person sitting at his desk. And let's say this is his desk. Right? And so essentially this is his primary zone. Let's draw that in yellow. Primary zone. And his secondary zone would be out here somewhere. How far he can stretch. Stretching, or let's say reach. And then this yellow without reaching. And so this is his work envelope, right? But he also has this area on the outside behind him, right? And then we'll have something like this around him. And we'll even have on the three-dimensional axis, we'll have like a sphere. Oops. We'll have a sphere of this person. And so that's actually how it works. Let's shift back to black or blue, right? And so that is question 3. Static and structural just means stationary. Now, these two don't really make sense, right? These are kind of oxymorons, and so our only options were really these two because we can't have static data and functional data, right? Functional and dynamic go together, and we have static and structural that go together. So it's sort of a trick question. Now, question 4. The city of Kwinana in Australia has designed a simple and cost-effective solution to deal with the discharge of waste from drainage systems. They have placed large nets over the drainage pipe outlets. What type of clean technology are the drainage nets an example of? So, this is sort of what we call metaphoric, right? Clearly, it's an end of pipe technology, but we put it at the end of a pipe. Uh, Systems level solutions means it's a across the board from government to businesses to small scale local community. That's what a systems level solution is. It goes throughout the process, right? Throughout process to deal with with the system as a whole, right? Whole system, not just components. Then we have green design, which just means taking into account environmental impact, right? Throughout life cycle of the product, throughout product life cycle, life cycle or lifespan, right? And radical solutions, which just means going back to the root of the problem, going to root problem and just solving it in a completely different way that has not been done before. So, uh, completely, completely different solution to the same problem, right? Solution, or approach, right? Or just attitude towards the problem. And so you develop a new product or system. Now, this is a, let's say, different approach, but this is quite conventional, right? You just capture waste product at the end of a process, and that is what end of pipe technology is. It is a clean technology, but it is not the best. Not the best. It is sort of a uh, minimum effort solution, right? Minimum effort solution. And that is what most people want to do, right? Most businesses do not want to spend money. So let's say cheapest as well, right? Let's put that in green. Cheapest solution. And so those are things you can talk about. So that's why it's A. And now we're on to question 5. What is the term used to describe the total energy required to produce a product? That is our embodied energy, right? That is the exact definition. So there's no reason for me to define it. Stored energy. Now let's break down the other options. It just means storing. So energy is produced. Energy produced. Let's say during the day. During day, then stored during night, let's say. That is typically what happens during night. And usually batteries, or we have pumped. So we would have lithium ion uh, right? Lithium ion, we have hydroelectric uh, pumped storage. That is where we have a reservoir and we pump water back up, pump water up uh, into the reservoir, uh, into the reservoir for storage, which can then be brought down to create energy through turbines, run through turbines later, through turbines for energy. And then we also have other sources like thermal, molten salts, but we don't need to go that far into depth. We have fuel cells, right? That's just for your understanding. Uh, Now we have energy security, and this is actually topic 8, right? So this is a HL idea, topic 8. And what we have is energy security just means we want 24/7 availability at affordable prices, right? We don't want constantly fluctuating really high prices like we do for what is it? Petroleum, diesel, and nowadays because of the Middle East war at affordable prices. So 24/7 availability, uninterrupted is the keyword, right? Uninterrupted. And then we have energy utilization. That's pretty, I guess, straightforward, which just means what method are we using? How are we using? Uh, how are we using energy is what this means. Next is question 6. Which design strategy is described as designing in a way that takes account of the environmental impact of the product throughout its life cycle? So, inclusive design not related, we can define that. UCD not related. So it's either eco design or green design, right? Most of you would be stuck there, and for those of you who do not know the difference, that would be a tough 50-50 guess though. So our correct answer is green design. For the reason we defined this above, right? Green design is taking into account environmental impact throughout the product's life cycle or lifespan. And so I'm not going to define that again, that this is the exact definition. And so eco design is actually it's related to the materials, right? It's a approach, it's a strategy, or let's say design strategy, right? That's what we've been talking about in DT, design strategy. And it focuses on 3 main categories, and that is number 1, uh, materials, right? I think some of you may have seen a few questions on this. Then we have pollution. We want to reduce pollution. We want to use sustainable materials. We want to reduce the waste of material. And then we also have, so this is pollution or waste. So any emissions or greenhouse gases, we want to reduce those. Then we also have energy, and that is where we want to, in production. So in production, in the use of production, transportation, uh, use, disposal. We don't want to incinerate, right? Incineration. Then we have pollution and waste. We do not want to, again, incinerate. Dispose and landfills. Uh, what else? Materials. We want, let's say, biodegradable, non-toxic, toxic, right? So these are things we should be thinking about. We want materials that don't need a lot of treatment, uh, deforestation, and so here's well, production means, let's say, extraction of raw materials. So we want to reduce that. Let's say renewable. So these are keywords to remember when we come to those 9 markers, 6 markers, And inclusive design, I think we should know what this is. This is topic 7 though, so HO again. Let's say, don't have much space, but usable or accessible by as many people as possible. Uh, Largest, what's it called? Percentile range. Uh, or proportion of the population, we can say. And the thing is, we do not want to adapt our product, right? Without adapting or making a new product, without adapting, without need to adapt or create a specialized, design. Adapt or specialize, right? So that means it's usable by everyone, including those who typically would not be able to use that kind of product. And then we have user-centered design. That means user needs, task users, sorry, paying attention to the user's needs, tasks, task environment, right? Those are the 3 main things we want to target. And then understanding that we have to involve them, users, throughout the design process, throughout design development process, design process. Hopefully that makes sense. Now we move on to question 7. Which renewable resources can provide a constant stream of energy? We have solar, not really. Without sun, it's poof. Without sun, poof. Geothermal, right? And so this is so solar would be similar to wind. Even wind would be not possible. And geothermal and hydroelectric. So let's discuss that. So our answer is 2 and 3, and that would be C, right? Now let's talk about why it's hydroelectric and geothermal. So hydroelectric, let me bring this down so we have more space. Hydroelectric is where we use oops, give me a sec. Yep. The continuous flow, right? Continuous flow of water or water cycle. We know that we have a water cycle, right? We learned that in maybe primary school. Cycle of water, evaporates and then falls down from the clouds. So we're using that continuous cycle of water and gravity, which then brings it down into reservoirs. And water is renewable, right? It's replenishable. It's always there. Always there. uh, continuous. It's not going to run out. So what we have is gravity. So essentially we have a dam, right? And our water comes down, and we have water up here. We have a dam, and then we have water come down to this reservoir. And we have turbines in here that generate electricity because we're dropping uh, where there's a drop in the height, which creates energy, and that helps turn our turbines due to gravity. The energy is due to gravity, and that causes the water to flow out and generate electricity in the generators of the turbine. Definitely go check out some videos or research that. It's hard to explain in something like this, but you've definitely heard of it before. And the thing about hydroelectric is they can continuously, adjust or adjust or adapt generation uh, based on demand just by the switch of some buttons. So based on demand, so that is important. And then we have the fact that I mentioned above, we have these the reservoir storage, right? Pumped water up. So we have a storage of water in reservoir when energy is not needed or when energy demand is low. And so even when there's no rainfall, even when no rain, uh, there is sufficient water to generate electricity. Okay, so that is hydroelectric. Now we move on to geothermal. Let me use some blue to spice things up. Now, geothermal is not impacted by weather, right? It uses heat from the Earth's core, not impacted by climate or any sort of other thing like solar or wind. It uses the, let's say, uses flow of heat from Earth's core, and from Earth's core we have some radioactive materials that emit that radioactive decay that generates energy, and so that is continuous. 24/7. So hopefully that's sufficient for you guys and you understood that one. We'll move on to question 8 and we'll end on question 8 so that this video doesn't get too long. Now what we have is a core philosophy of a circular economy. This is obviously just cradle to cradle, right? Everything in our circular economy, we want it to be in a continuous loop, right? We want to be recycling materials, industrial symbiosis. You guys can search that up. It's a nice word that I like to use. Using materials from one industry or waste from one industry as a resource for another industry. Biomimicry is just a design inspired by nature, and usually it's more efficient, usually more efficient right? Cradle to gate is just cradle to grave, sorry, is only considering from design to disposal. Then after that, the environment does not matter. So environment impact from considers environmental impact from design to disposal. Uh, and then after that, it is left, right? So there's no recycling of materials, and it's not really a circular economy. It's a take, make, waste with some consideration. Cradle to gate, sorry, cradle to grave. Cradle to gate is even worse than that. It is just design to end of production. And then after that, the environment is not considered. Considers, right? So, yeah. Hopefully these notes are not too much. I'm just trying to get all of the topics. It sort of helps, right? And we'll move on to question 9 later. We already hit 30 minutes. Hopefully that's good. And you guys learned a lot more than you do maybe in class. And don't look at a mark scheme. Uh, yeah. So all of these are the correct answers. And do like and subscribe if you learned something. And more videos coming soon. I'll cover the rest of this later.